Hi folks, welcome back. I hope you're all doing well. I came across this paper on Ethan Malick's LinkedIn stream, and it is a very interesting paper. It looks at how humans and AI agents execute the same workflows and then compares how they do it differently or similarly. And why is this interesting? Why should we do this? Because if you compare the ways in which humans and agents perform the same work differently or similarly, you can learn about the strengths and weaknesses of agents today, but also, more importantly, learn about how humans and agents should be collaborating. The age-old augmentation versus automation question in AI agents. So I want to take a deeper look at what they did, how they did it, what their results are. But I do have one major concern about the methodology and the findings as a whole, and I'll get into that towards the end. Okay, so let's start at the very beginning. You first have to come up with a set of representative and non-trivial tasks. And the way they start off with that is to use this ONET database from the US Department of Labor, which catalogs pretty much every occupation in the labor force and what the task requirements are. And then they filter it for things that are amenable to using computers, are amenable to automation, and also factor out common tasks that are performed across occupations. And after doing that pre-processing on the ONET database, they zoom in on these four skills: data analysis, engineering, computation, writing, and design. And this gives you pretty good coverage of a large slice of the data force. As they say over here, it affects 287 computer using occupations and about 72% of their daily tasks. And just to give you a concrete feel for what these tasks look like, here are some real examples. Computing the variance in a budget, doing some data analysis, and then creating slides out of it, analyzing bills for an outing, validating expense reports, creating a 10K income report. So these are all tasks that knowledge workers have to do pretty frequently. Okay, now that you have the tasks, step two is to actually execute them, and you need two substrates. One is the agentic one and one is the human one, and then you're going to compare the two. For the agentic execution platform, they used the agent company, which is basically a setup where you create a sandbox environment for each specific task and give it everything it needs. So whatever inputs it needs, whatever software it might need to perform that tasks, and then you set it off with a task instruction. And of course, you have all the basic Unix things like Bash and Python and so on. And then on the human side, as they say over here, they got 3 human workers from Upwork for each task. And they did some filtering to make sure they had the right skills, they were experienced enough. And these humans, while they were performing these tasks, their computer activities were recorded. Now, the next important question is, what agents were used for executing the agent side of the tasks? So they use ChatGPT agent and Manus. And of course, ChatGPT agent is built on GPT-5, and Manus is built on the Claude family of models. And they used a third one. There's an open source agent called OpenHands. And they're saying at the time they used GPT-4o and Claude Sonnet 5, which is, as of this recording, the kind of previous generation of models, but maybe this was the best when they ran the study. And of course, you can do logging and instrumentation to collect traces of what the agents did when solving these tasks. At the end of all this, they ended up with 64 agent trajectories and 48 human trajectories, and this surprised me a little bit. The agent trajectories were about 34 steps on average, whereas the human trajectories were much, much higher, 981 steps on average. So this is good because this is a much higher number than a lot of previous benchmarks had seen. So these tasks are more complex, more realistic. Before we get to the results, I want to highlight one more cool thing that they did, which is actually very worthy of in-depth coverage on its own, but I'm going to gloss over it in this video for the sake of time. And that is when you record the activities performed by a human on a computer to perform a given task, you end up with these very low level events like which keys they pressed and what they clicked and where they clicked. And out of this very low level stream of events, you have to then construct a higher level set of tasks that they did, which when strung together results in execution of this larger, more complex task. So for example, all of these key presses mean that they installed Python and they installed some Python libraries. So this is what they call inducing a workflow. So taking these low level actions and coming up with a higher level set of steps. And this on its own is actually a very valuable thing to do. But that was one of the steps they had to do to come up with the comparison for how humans and agents perform these tasks. Now let's look at the results. You have trajectories for human execution and agent execution for the same set of tasks. How do they compare? At the highest level, they found broad agreement. Human and agent workflows share 83% of steps. And in fact, the orders of those steps were preserved for 99.8% of the time. So looking at it from a very high level, it seems that humans and agents are performing their tasks very similarly. But if you dig deeper, there are some very important differences. The biggest difference by far is the tools that agents use to perform their tasks. As they point out over here, humans prefer to use UI interfaces, so typing things into a UI or clicking things on the computer. However, agents lean heavily towards writing and then executing code. So they use programmatic tools like writing a shell script or writing some Python. And they lean towards coding so heavily that they use coding not only for software or engineering kind of tasks, but even non-engineering and more visual tasks. This is, of course, not a huge surprise because coding has been a strength of models, large language models, since the very beginning, and it continues to be a big strength. Now, a very important part of the study is the different modes in which humans use AI tools. And they found that 75% of the humans in the study used AI for augmentation. And what that means is that the human is still driving the overall end-to-end task, but they will delegate a very specific task in that workflow to AI. And this will usually be a very well-scoped, well-specified task. On the other hand, with automation, they are delegating much more of the end-to-end workflow or the entire task to the AI. And now they're not so hands-on, they're not driving anymore, but simply reviewing the solution at the end that the AI gives to them. And here is one really important finding. When people used AI for augmentation, it sped them up by 24%. However, when they used it for automation, it slowed them down by about almost 18%. And the reason for that slowdown was that they had to spend more time verifying and debugging and correcting AI's solutions. Okay, but what about end-to-end success? And here again, they found a big gap in the success rates between agents and humans. So in this graph, the agent is blue, the humans are yellow, and you can see a 30, 40%, sometimes more than a 50% gap between human success rates and agent success rates. On the other hand, of course, agents, when they are successful, perform the task much, much faster and are much cheaper. Now, one of the headline findings of the study is the failure modes they found with agents. And this diagram lays out the four big failure modes they found, and they all have to do with reward hacking in some sense. So, one example is agents fabricating data or fabricating work. And this example is from extracting data from receipts. And when the agent couldn't extract the right data, it just made up some data. Another one is misusing tools or using tools when you don't want it to. And here again, they give a concrete example where they pointed the agent to a bunch of local 10K reports and wanted the agent to look at those very files. However, the agent went and did a web search to find 10K reports for those companies, even though it had it locally on files. And then, in terms of quality of the output, they noted how humans will have just much better, much more readable formatting, and also humans will consider a more practical range of solutions, such as building a website that is responsive as opposed to just for desktop. Though I think these last two are more problems of detailed specification or lack thereof, rather than reward hacking like these first two. Now, based on these findings, the authors have proposed a framework for how humans should be delegating work to humans, and it basically revolves around the programmability of a task. What they're suggesting is that if a task is easily programmable, things like cleaning data or coding up a website, you can safely delegate them to agents. There's a gray area in the middle where a task seems like it's fairly programmatic, but the agent may not have the right tools or the right APIs to write an execution plan or a program against. In that case, you should be focusing on creating such APIs or tools. And finally, for the least programmable kinds of tasks, which have to do right now with computer use and vision understanding, you should still rely on humans. So I think that mostly makes sense. So overall, this is a really valuable study because if you do a head-on comparison of how agents perform work versus how humans perform work, it gives you all these really deep insights, especially the failure modes of agents. My one big concern is the way in which these agents were set up for this task. So they use ChatGPT agent and Manus and OpenHands, which is fine, but they basically give these agents the description of the task as a prompt, and then the agent goes and runs by itself. So it comes up with a plan by itself and it executes that plan. The problem is that if I were to seriously develop an agent for a task like this, say a task of understanding expenses and their receipts and then filing expenses, I would never actually just give that as a prompt to ChatGPT agent or to Manus. I would actually spend time understanding what the task is, what the error modes are, what all the edge cases are, how humans do it, and then build a very custom bespoke agent to perform that task. And there's existence proofs of things like this all over the place. For example, if you use RAM for expenses, it has a nearly perfect mechanism to take in images of receipts and create correctly formatted expenses out of them. And so that is a very, very specific agent for that specific task. And so I think this methodology is very generic and it's too open-ended. So you're not actually building task-specific agents. And they mentioned that in passing, but I think that is a very important point. So the comparison here is with the bare minimum simplest agents that you could construct, not really the best agents that you could make, which of course would take a lot more effort than simply prompting a generic agent. So that's my only caveat with this study, but otherwise very illuminating. I hope you found that helpful. If you like content like this, please consider subscribing, like the video, and I will see you next time. Thank you very much.